Welcome to Tutors. Today what I'd like to do is show you how to solve quadratic equations. Now before we can go ahead and solve quadratic equations, we need to understand what exactly is a quadratic equation. And a quadratic equation has some properties that distinguish it from, say, linear equations. A quadratic equation is in the form of ax squared plus bx plus c, where a, b, and c are integers, real numbers, and a cannot equal 0. If a equaled 0, we wouldn't have an x squared term, and therefore we'd be left with bx plus c, which is just like a linear equation. Now, when solving quadratic equations, there are a lot of different techniques that are going to help us solve the problems. They're not always the same like they were linear equations when we use inverse properties. Solving quadratic equations can be sometimes difficult, but a lot of times just using the technique that you are most comfortable with and that helps you solve the quadratic equation the best. So a couple methods that I wanted to go over with you in this tutorial is first using the square root method. Second is doing the factoring method, completing the square method, and also using the quadratic formula. So for the first one, which we call the square root method, what you're going to do is you're going to isolate the variable. Now, a lot of students like this method a lot because it reminds them a lot of solving for linear equations. What you're going to do is you're going to get your x squared by itself. You're going to isolate it. So therefore, I have an x squared plus 8. To undo my operation of adding 8, I'm going to subtract an 8 on both sides. Now, my equation reads x squared is equal to negative 8. So to solve for my x, I need to now undo the squaring by taking the square root. Hence why we call it the square root method. So here what I did was, remember, when you take the square root of a number on both sides, you have to make sure that we include the positive and the negative value of that x. The next thing I did is, this is what we call when you can't take the square root of a negative number. So this is what we're going to be calling a imaginary root. So my answer, my two roots, or my zeros for this problem, are actually going to be what we call imaginary, where this I represents that negative 1 under my radical. So when we're solving quadratics, this is something that's going to come about. So I want to make sure that you understand, if you have a negative, you can factor out a negative 1, which we call I, outside your radical, and then also make sure you simplify your radical in your lowest terms. So square root of 8 can be reduced down to 2 times square root of 2. The next one is factoring, and a lot of us have had a lot of practice with factoring. So really what we're going to do is we're going to use our factoring skills plus the zero product property to solve the equation. So here I have x squared minus 11x plus 18. Now, what I like to do to solve my factoring problems is I like to write my 8 times c and my b in what we call a little diamond problem. So I take my a times c. So here my a is 1 times 18 would give me 18. And then I take my b, which is a negative 11. So now what we will need to do is look at what two numbers multiply to give me 18, but then add to give me a negative 11. And your two factors for 18 that add up to negative 11 would be negative 9 and negative 2. Therefore, now I can write this as x minus 9 times x minus 2 equals 0. So what I've done is I've rewritten this quadratic as two binomials multiplied by each other. Now, the reason why I want to do this is because now I can use the zero product property. A lot of students get mixed up with this and they try to solve by using the square root method. We have to be careful and understand that when you have an x squared and an x, you can't isolate one variable. For here, it was easy to isolate because there's only one variable. When I have two, I'm going to have to come up with a different method. So here with factoring, it works. So I can factor it to two binomials. And then what I can do is now use a zero product property that states whenever you have, a times b, you have a equals 0 or b equals 0. So therefore, now I can write this as x minus 9 equals 0, or x minus equals 0. Therefore, my two zeros, when I solve for x, I get x equals 9 and x equals 2. So therefore, those would be my two answers for this problem number 2. Completing the square, the love of so many students. So completing the square, there's a couple things we need to remember when we're trying to complete the square. First thing we need to remember are b over 2 squared. All right? And when you want to complete the square, and I'm just going to do kind of a brief overview, our whole purpose is to get a trinomial into a perfect square. So to do that, what I'm going to have to do is I'm going to have to take our middle term, divide it by 2, and then square it. So for this term, I have 12 divided by 2, which is 6. 6 squared is 36. So for this answer, my b divided by 2, which is 12 divided by 2, equals 36. So I'm just going to kind of do that on the side so you guys can see it. So what I'm going to do now is I'm going to write my first two terms in parentheses. So I have x squared plus 12x minus 5 equals 0. Now remember, we're going to be trying solving this, all right? So what we're going to do is we're going to add a 36, that's my middle term, to both inside on the left side, we'll say on the left side of my equation, and also to the right side of the equation. Now the whole purpose, I'm going to add this inside my parentheses, and the reason why I'm going to do that is because now what I've done is I've created a perfect square binomial, which I'll show you in just a second. So I'm going to add the 36 inside my parentheses, and then I'm also going to add it outside. Because remember, whenever we're dealing with equations, you have to make sure whatever you add on one side, you have to add on the other side. So I'm going to add a 36 on both sides. Well, now I'll add the 5 to the other side. And now what we can do is, see here I have another trinomial, but like I said, it's a perfect square. So what I can do is I can say, well, what two numbers, how can I rewrite this? What two numbers multiply to give me 36, add to give me 12? And what we say is we can say x plus 6 squared equals now 41. And what's so helpful about this is what this has now done is they've kind of allowed us to very similarly solve this like the square root method. Now all I need to do is to get rid of my square is to take the square root. So now I have x plus 6 equals plus or minus the square root of 41. And then to finalize this, getting my x by itself, I need to subtract 6. So my final answer is going to be x equals negative 6 plus or minus square root of 41. So, the quadratic formula is the last topic I like to go over. And the quadratic formula is a very basic formula where we're just going to take our values for a, b, and c and put them into the formula. Now, a lot of students, once they learn the quadratic formula, they want to forget all these other methods. And I'm just here to tell you, with practice, using these methods will be very, very, very helpful. You should recognize whenever you have your first term, only an ax squared, and a constant, the square root method is very quick. Factoring. If you can automatically determine your a, c, and your b, and that works, a factor method is very quickly. Sometimes it takes a lot of thought and you got to think through it, but with practice, factoring is very quickly. Now, if you can't factor it and it's not in your square root method, completing the square is a very easy method that with practice you can work through it and solve any quadratic. Now, quadratic formula, we got to first remember what the quadratic formula is. So you can look through songs and games and all that kind of stuff, but if you just remember, it's going to be the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And obviously, my a, b, and c all relate to the general form of a quadratic equation. So what I'm simply going to do is just plug in my values for a, b, and c. Remember, a, since I do not have a So since I do not have a number in front of my x squared, we know our number is actually 1. That's the coefficient. The coefficient of my b term is -5, and my c is 3. So the opposite of -5 is going to be +5, plus or minus. Okay, so here what I notice is I have 5 squared, which is going to be 25, minus 4 times 3, which will be 12. So I'll have 5 plus or minus, let's see, 25 minus 12 all over 2. And then I can reduce this similar down to 25 minus 12 is 13. So I will I'll have a little bit more room here. So I have 5 plus or minus the square root of 13 over 2. And a lot of students will understand this and say, okay, I get to that point, I can't simplify this, anymore, but what does that equal? Well, remember, we're solving, right? But what values are we solving for? We're solving for our x's. So therefore, I can write, yes, those are going to equal my two x values. So the zeros for this property, you're going to have 5 plus the square root of 13 divided by 2. And also you're going to have to find 5 minus the square root of 13 divided by 2. And those will be your two values for x. Now, there's one more method I wanted to show, and it's just another type of factoring. Because when you're looking through factoring, or really actually even doing both of these, especially completing the square and factoring, it's always helpful to see how can you simplify the problem. And for this problem, always want to see if I can factor out a GCF, or the most common factor. And so that's exactly what I'm going to do for question number 5. I notice that both of these terms have an x and a 3 that I can factor out. So now, by factoring out an x, what I've done is again created another problem where I can use the zero product property. So I can set both of these to now equal 0. And by solving for x, what I've now created is x equals 0 and x equals 5. So, ladies and gentlemen, that's a quick overview of solving quadratic equations. Just remember to test if it's a quadratic equation, look to see you have ax squared plus bx plus c. And then the next thing is just try to look at all 4 of these solving methods. And don't get good at just one of them and forget about the rest of them. It really will be helpful to understand each one of these methods and for which type of quadratics they'll best apply. So I hope you learned something good today, and go back and visit me more at tutors.com. Thank you.